This is my Newton's second law, reassessment, chapter 3. And the problem that I chose is question 112. The coefficient of static friction between a brick and a wooden board is 0.40, and the coefficient of kinetic friction between the brick and board is 0.30. You place the brick on the board and slowly lift one end of the board off the ground until the brick starts to slide down the board. What angle does the board make with the ground when the brick starts to slide? What is the acceleration of the brick as it slides down the board? So, label what you know. I drew the free body diagram of the brick sliding down the board. And so, come over here, summation of the forces is equal to mass times acceleration. So, summation of the forces in the F direction are the static friction force minus mg sine theta, because sine is the y component of mg, or x component of mg, I'm sorry. And summation of f of y is equal to n minus mg cosine theta. And when you have these, you just f of x, you solve for both of these, so you add mg sine theta to each side, and you get f, the force of static friction is equal to mg sine theta. And then you get n, the normal force, is equal to mg cosine theta. And so you, for x, for static friction force is equal to the coefficient of static friction force times the normal force. You plug that in for, or you substitute it for static friction force, and you get the coefficient of static friction force times the normal force is equal to mg sine theta. And so coefficient of static friction times mg cosine theta is equal to mg sine theta. Coefficient of static friction is equal to mg sine theta divided by mg cosine theta. You divide mg cosine theta to both sides, and you end up with tangent theta. So the coefficient of static friction is equal to tangent theta. So to find the angle, you go tangent negative 1, or inverse tangent of the coefficient of static friction is equal to theta. And when you plug the coefficient of static friction in, which is 0.4, you get 21.8 degrees. Now, to find the acceleration, force is equal to mass times acceleration, and you're looking for the net force. So the net force would be mg sine theta minus coefficient of kinetic friction, mg cosine theta. And once you rearrange here, you find the acceleration is equal to force divided by mass. And so the acceleration is equal to mg sine theta minus coefficient of kinetic friction, mg cosine theta, divided by m. Because you have an m in the top and the bottom, you can cancel those out. So the mass cancels. And then you are left with acceleration is equal to g sine theta minus coefficient of kinetic friction cosine theta. I also factored the g out because there's a g in each term. Then once you get here, you just come down and you plug in what you know. Gravity is equal to 9.8 sine of theta, or 21.8 because that was our angle, minus 0.3, which is the coefficient of kinetic friction, times cosine 21.8 is equal to 0.91 meters per second. So the acceleration is equal to 0.91 meters per second.